everyone, welcome to Math World. This video is to discuss the Cambridge International AS and A-Level Mathematics for Paper 1, Pure Mathematics 1. And this exam diet is May-June 2022. The code for this paper is 9709/11. Okay, so let's move on to question number 1. Now 1a, express x squared minus 8x plus 11 in the form of squared x plus p plus q, where p and q are constants. So to get this form, basically we need to carry out the completing the square method. Okay, so first of all, I will rewrite the quadratic function. So according to the completing the square method, right, the coefficient for the x squared must be positive 1. So now you can just rewrite the first two terms, x squared minus 8x plus square of the bracket minus square of bracket, then plus 11. So for the brackets, we need to get the coefficient of x and divided by 2. So which means it is minus 8 divided by 2. Okay, for both brackets. So then after you get this, we just need to combine the first and third term, which is x minus 8 over 2 is minus 4. Okay, then we put the bracket, after that squared outside. Then now same for the fourth term. It will be negative 4 squared plus 11. Okay, so from here we can simplify and get the answer as square of x minus 4, then minus square of negative 4. This is basically minus 16. Minus 16 plus 11 is minus 5. Okay, so that is the form that we need to write. Now B, hence find the exact solution of the equation x squared minus 8x plus 11 equals to 1. Hence means use the previous answer. So now you will notice that the left hand side, x squared minus 8x plus 11 will be square of x minus 4, then minus 5. So I will replace the left hand side by this. So x squared minus 8x plus 11 equals to 1. I will change to x minus 4 squared minus 5 equals to 1. So from here, x minus 4 squared equals to 6, right? After you move the minus 5 to the right side, it becomes 6. Then to eliminate the squared, I will get plus minus square root 6. So at last, x equals to 4 plus minus square root 6. That's the exact solution. Alright. Now, question 2. The 13th term of an arithmetic progression is 12. So, arithmetic progression, 13th term is T13 equals to 12, which means A plus 12D is 12. This is the first equation. And the sum of first 30 terms is negative 15. So, S30 is negative 15. So formula is n over 2. Your n is 30 now. So 30 over 2 bracket 2a plus n minus 1. So your n is 30. So minus 1 becomes 29. D equals to minus 15. So from here, I simplify. This is 15. So since left hand side you have 15, right hand side also 15 here. Okay, so I can cancel off. So here becomes minus 1. That means my simplest form will be 2a plus 29d equals to minus 1. This is my second equation. So to solve this question, I can times the first equation by 2. Okay, so when I times the first equation by 2, I will get 2a plus 24d equals to 24. That is my third equation. Then to solve this, right, the question says find the sum of the first 50 terms. So I have to find the a and d first. So to solve these two equations, second and third, I can use second equation minus third equation. So 5d on the left hand side, right hand side will be minus 25. Therefore my d is minus 5. Okay, so once I have found the d, I can find the a from the first equation. So now my a is basically 12 minus 12d. So I replace the d So it becomes 12 minus 12 times negative 5. So then you will get 72. Alright, so now find the sum of the first 50 terms. So S50. S50 is 50 over 2. 2a, a is 72, plus n minus 1d. So your n minus 1 is 49. Then the d is negative 5. Then at last you will be getting negative 2525. That is the sum of first 50 terms. Okay, so now question 3. The coefficient of x degree 4 in the expansion of degree 5 for 2x squared plus k squared over x is a. The coefficient for x squared in the next expansion is b. Find a, b in terms of k. Alright, so from here, 2x squared plus k squared over x degree 5. So I can write this as summation 5r. First term is 2x squared to the power of r. Then k squared over x to the power of 5 minus r. The r from 0 to 5. Okay, so now here I can split all the terms because our constant is the x degree 4. Alright, the coefficient for x degree 4. So now instead of writing degree r of 2x squared, I will write 2 degree r, then x degree 2r. Because when you write x degree 2, then to the power of r is same as x degree 2r. Okay, then the next one is k squared. So k squared degree 5 minus r. Then the x at the bottom is actually x power negative 1. So I'll write x power negative 1 to the power of 5 minus r. Okay, so now you are given x degree 4. Okay, so now I need to find what is the r to give you the x degree 4. So what x degree 4 means that here is x degree 2r multiplied by x degree. This negative 1 you times in or times out. So I will get to the power of minus 5 plus r. Okay, so when you get the same base, we have the formula ab power, I would say the formula is a to the power n times b power n. It will be a to the power of, it should be the same base. Okay, same base. Here is a, so it will be a to the power of m plus n. Alright, because both also base x. So now I'm going to add the degrees. So here, x degree 4 equals to x to the power of 2r plus times minus r minus 5 plus r means minus 5 plus r. So now 4 equals to 2r minus 5 plus r means that 3r is 9. Therefore, my r is 3. Okay, so when r equals to 3, my coefficient of x degree 4 is a. So it means that now my a equals to, the coefficient is after you have replaced all this, right? All of this will be the coefficient for x degree 4. So now I will get a equals to 5 3 2 power 3 k squared to the power 5 minus 3. Okay, just substitute into the red arrow. That will be the coefficients. So 5c3 times 2 cubed, right? So these two terms, when you times together, is 80. Then 5 minus 3 is basically 2. This is 2. So 2 times 2 is 4. That means you are getting 80 k degree 4. That is our a. Okay, so now the coefficient of x squared in the next expansion is b. So again now 2kx minus 1 to the power of 4. We need the coefficient for x squared. Right? So use the same method to get the r. Summation for r 2kx to the power of r minus 1 to the power of 4 minus r. The r from 0 to 4. So now here, I will split it, right? So it will be a summation for r, 2k to the power of r, x to the power of r, minus 1 to the power of 4 minus r. And the r equals to 0 to 4. So now, you are given x squared. Okay, so our constant is the x squared now. X squared equals to, this is the only x. That means it's x degree r. So obviously your r is 2. So now b is going to be the coefficient for the x squared, which means it will be all these terms. Alright, so I will get for C2, 2k to the power of 2, because the r is 2, then minus 1 to the power of 4 minus 2. So you will get 24k squared. Alright, that's the solution for A and B. So this is our answer. These are the answers. Right? Now B, given that A plus B is 216, find the possible values of K. So A plus B is 216. Alright, and then your A is 80k degree 4. And then the B is 24k squared. So when you substitute all this into the A plus B equals to 216. Right? So I will replace now 80k degree 4 plus 24k squared minus 216 equals to 0. So from here to solve this question, we need to simplify first. Alright? Hold on, please. Okay, so first of all, I will let I will let u be k squared. That means 80u squared plus 24u minus 216 equals to 0. Okay, so now from here I need to find the common multiple. Alright, so let's say divide by 6 divided by 4. Okay, all divided by 4. So 20u squared plus 6u minus 54 equals to 0. Alright, so now we can further simplify this to be 10u squared plus 3u minus 27 equals to 0. Alright, so now I can use quadratic formula to solve this question. So u equals to, I will write down my a first. So my a is 10, b is 3, c is negative 27. So my u becomes minus b plus minus square root of b squared minus 4ac over 2a. Okay, so I will get minus 3 plus minus square root of 1089 then over 20. Okay, so now you need to find possible values of k. So means now your solution will be 3 over 2, and another one is going to be negative 9 over 5. This is how you get it using quadratic formula. Otherwise, you can just factorize it. Okay, so once you have found the u, now we know that u is k squared. So I will replace back. So now k squared equals to 3 over 2. Then from here, your k is plus minus square root of 3 over 2. Okay, but when k squared equals to negative 9 over 5, we know that this is no solution. Okay, therefore, your final answer k is plus minus square root 3 over 2. So that's the solution of this question. Right. So now for A, prove the identity. Sine cube theta over sine theta minus 1 minus sine squared theta over 1 plus sine theta. Okay, so from here, sine cube theta over sine theta minus 1, I will start with the left hand side. Now, to get the tangent, before that, I will get the same denominator. So here is going to be sine theta minus 1 multiply with 1 plus sine theta. Then now we just need to use cross multiplication. So sine cube theta multiply with 1 plus sine theta minus sine squared theta multiply with sine theta minus 1. Okay, so from here, before I expand, I will factorize a common term. So obviously the common term is a sine squared theta. Because I get the sine squared theta, I can factorize the sine squared theta from the first term in the numerator as well. So I will factorize sine squared theta. Okay, then you still have sine degree 1 theta here and multiply to the bracket. Then it will be sine theta plus sine squared theta. Then minus, bring in the minus, it will be minus sine theta plus 1. Then over sine theta minus 1 multiply with 1 plus sine theta. Okay, so now from here, I know that the denominator, now basically we have a formula here. A minus B times A plus B is A squared minus B squared. So I will say that this is my A. This is my A, this is B, this is A, this is B. So A minus B times A plus B is basically A squared minus B squared. So now the denominator I can change to sine squared theta minus 1. Okay, and for the numerator, inside the brackets, I can cancel off the sine theta because 1 plus 1 minus. Then I will get sine squared theta plus 1. Right? So now, by looking at the question, we need to get 1 plus sine squared theta. So I already found 1 plus sine squared theta here. Okay, let me check. Then I need to get tangent squared theta and together with the minus. So to get tangent squared theta, we need to have sine over cos, right? Sine squared theta over cos theta. Therefore, now I have to use formula sine squared theta plus cos squared theta is 1. And now by looking at the denominator, this is sine squared theta minus 1. So it means you move this one to the left hand side and this cos squared theta will be moved to the right hand side because minus cos squared theta. So I will be getting negative, or I will be getting sine squared theta multiply with sine squared theta plus 1 over, this is going to be negative cos squared theta. Okay, then now to get 1 plus sine squared theta, then I have to rearrange it, and at the same time sine squared theta over cos squared theta is negative tangent squared theta. Then multiply with 1 plus sine squared theta. So this is how I prove this identity. Okay. Now B, hence solve the equation. So just now we have proven this. the left hand side. So the left hand side is basically minus tangent squared theta multiplied with 1 plus sine squared theta. Okay, so here I will just direct change the left hand side. So my left hand side becomes minus tangent squared theta multiplied with 1 plus sine squared theta. Then right hand side just remain tangent squared theta multiplied with 1 minus sine squared theta. And the theta defined from 0 to 2 pi. Alright, so from here, we do not cancel off the tangent squared theta even though they are in common. So what we do is, we will just move all the terms to the left hand side. So I will get minus tangent squared theta, because now you need to solve. If you cancel off the tangent squared theta from both sides, then you will be missing few values. Okay, once you have factorized, then now I know that my common term is minus tangent squared theta. So I will factorize the common term. Then I will get 1 plus sine squared theta. And this minus already taken out means that you still have plus. So this plus multiplied to the bracket, it will be plus 1 minus sine squared theta. That equals to 0. Okay, so from here, the sine squared theta and minus sine squared theta will be cancelled off. That means inside the square bracket, it is just left 1 plus 1, which is 2. So I will just write minus 2 tangent squared theta equals to 0. Alright, so means that tangent squared theta is 0, because 0 divided by negative 2 is still 0. That means the tangent theta is 0. So when tangent theta is 0, right, to get the complete solution, what we need to do is we sketch a tangent graph from 0 to 2 pi. So this is my tangent graph. Here is 2 pi. This is pi. Pi over 2 and 3 pi over 2. This is my tangent graph. Okay, so now when you look at here, tangent theta is 0 means that you get few solutions, 0, pi, and 2 pi. Alright, but then by looking at the domain here, the interval of theta, theta is greater than 0 but less than 2 pi means that we cannot accept exactly 0 and exactly 2 pi, which means your theta just pi for this question. Okay, so that's the solution for part B. Now, question 5. The diagram shows a sector ABC with, of a circle with center A, this is center A, and radius R. The line BD is perpendicular to AC. Here is perpendicular. CAB is theta radians. So CAB, right, all are given in the diagram. Now A, given that theta equals to pi over 6, 1 over 6 pi or pi over 6, find the exact area of BCD. So BCD means that this part. So obviously BCD is the area of sector minus area of the ABD triangle. Okay, so now to get the area of triangle, I need the AD. Okay, I need the AD because we have a formula. Let's say here ABC. The area of the triangle is AB times AC, half times AB, BC, sine theta. Okay, so now I need to use that formula. I don't want to count what is the dB. I just count AD. So to count AD, you refer to the Pythagoras theorem. The AD is the adjacent side of the triangle and the AB is a hypotenuse. Okay, this is adjacent, this is hypotenuse. So adjacent and hypotenuse means that is cos, right? So I will write cos pi over 6 equals to AD divided by R, hypotenuse. So from here, my AD is R cos pi over 6. So pi over 6 is square root 3 over 2. Therefore, you are getting square root 3 over 2R. That's the AD. Okay, now, area of BCD equals to area of sector ABC minus area of triangle ADB. Alright, so area of sector ABC is half R squared theta. Okay, so half R squared pi over 6. Minus area of triangle, as I have shown you just now, it will be half of AD R sine theta, sine pi over 6. So half of AD is the square root 3 over 2R, then R sine pi over 6. There's the area of triangle. And now you need to get exact value, okay? So the first one, you will get pi R squared over 12 minus this half times 3 over 2, square root 3 over 2R will be square root 3 over 4. R times R is R squared. Sine pi over 6 is half. Alright, so from here you will get pi R squared over 12 minus square root 3 R squared over 8. Okay, so that's the exact area of BCD. Okay, now part B. Given instead the length of BD is root 3 over 2R. Find the exact perimeter of BCD in terms of R. Okay, now BD is square root 3 over 2R. This is square root 3 over 2R. Now you need to find perimeter of BCD. So BCD here. Okay. So now the perimeter is basically BC plus CB plus BD. Alright? So then now we need to find what is our CB, okay, and what is our DB, right? DB is given now. Now means that, okay, you see, this pi over 6 is only for A, right? Means that now you need to find what is your theta right now when the BD is root 3 over 2R. Okay, so this is no longer, the theta no longer pi over 6. Right, I need to find what is my theta actually with this BD. And also the AB is R. So when you look at this triangle, okay, which means now the BD, which is root 3 over 2R, is opposite side. And opposite side of the theta, and the AB is hypotenuse, still hypotenuse, because here is 90 degrees. Here is a right angle triangle. So opposite and hypotenuse, we are going to use sine, which means sine theta is root 3 over 2R divided by R. Okay, in order to get the theta. So now I will start with sine theta equals to root 3 over 2R divided by R. So obviously, sine theta is root 3 over 2, which means the theta is pi over 3. Okay, so once we get pi over 3, now I will rewrite here. Your theta is pi over 3. Then I need to find what is my AD before I get the DC. So my AD, you can use Pythagoras theorem. R is a hypotenuse. This is the opposite side. Then to get the adjacent, I will just use hypotenuse theorem. So Pythagoras theorem. So my AD is square root of hypotenuse is R, so R squared minus the opposite side, square root 3 over 2 R squared. So from here, it will be R squared minus 3 over 4 R squared, and then square root. And then you will get square root of 1 over 4 R squared, which is half R. Okay, I found the AD. So AD is half R. So if AD is half R, DC will be R minus half R. Okay, so I will get my DC is half R. So now my DC is R minus half R, which is half R. Okay, so now I know that here is half R found. Now, next step is to get the arc length BC. Arc length is theta R. Now my theta is pi over 3. So my BC is theta R, which is pi over 3R. Okay, therefore the perimeter of BCD equals to DC plus BC plus BD. Okay, that means you are getting half R plus pi over 3R plus root 3 over 2R. Okay, so from here to simplify, you can take out the common denominator, which is 1 over 6. Then the numerator is R. So once you factorize 1 over 6 from half, you get 3. Then the next term will be 2 pi. And the last term is 3 square root 3. Okay, so that is the perimeter of BCD. Okay, now number 6. The function f is defined as follows. Fx is x squared minus 4 over x squared plus 4 for x greater than 2. Find the expression for f inverse. So for f inverse, we will let y equals to fx. So now I will write y equals to x squared minus 4 divided by x squared plus 4. And now you get the x as a subject. So multiply x squared or move the x squared plus 4 to the left hand side. So I will get y x squared plus 4y equals to x squared minus 4. Alright, then now y x squared minus x squared will be minus 4 minus 4y. So you group the terms with the x on the left hand side. And now get the x squared as a subject. So you get x squared bracket y minus 1 equals to, since both negative for the right side, I may factorize the minus. Then now my x squared will be division of 4 plus 4y and y minus 1. Okay, then from here I will get the x as a subject. So I will just take plus minus square root. Alright, this minus you can just move down, no problem. So it becomes 4 plus 4y over, so when you times minus to the y, it becomes minus y. You times minus to the minus y, it becomes positive 1. So I will say it is 1 minus y. Now, my f inverse equals to square root. The plus minus, I leave it first. So 4 plus 4x over 1 minus x. Now, how to decide the sign here, the plus or minus sign? It depends on your domain. Because we know that domain f equals to range f inverse. This whole expression is a range of f inverse. So now, range f inverse will be at least 2, positive. Therefore, this must be positive. And hence, my answer will be just positive square root. Okay, so that's the answer for inverse function. Now, show that 1 minus 8 over x squared plus 4 can be expressed as this form, and hence state the range of f. So now, to show the form, very simple, just get the same denominator. So when we get the same denominator, the 1 becomes x squared plus 4, then minus 8. So at last, I'm getting x squared minus 4 over x squared plus 4. Okay, this is the same as fx, exactly the same. Alright, so now again, we need to find range of f. So now, range of f. So I know that this is my fx, right? So that means this is my fx as well, 1 minus 8 over x squared plus 4. So by looking at the x values, the domain of x, your x is always greater than 2. So when x greater than 2, let's look at here. Alright, look at here. When x greater than 2, the denominator is positive. Right? So 8 divided by positive, it will be a positive number. So therefore, your range of the f will be between 0 and 1. Okay? Because, you see, look at here. I know that your fx, your x squared plus 4 is greater than 0. So when x is greater than 2, that means 2 squared plus 4, it will be 8 already. So 1 minus 8 over 8, I will write like that. Okay, so to explain this, right? So because your x is greater than 2, so x squared plus 4 is greater than 2 squared plus 4. That means it's greater than 8. So when 1 minus 8 over 8, it will be 1 minus 1, which is 0. That means it will be greater than this value, okay? It will be greater than 0. Because your denominator is greater than 8. But when exactly 8, it will be 0. So but then, when the denominator is bigger than 8, which means it's, let's say, for example, 10. So this one will be 1 minus 0.8. That means it's 0.2. So it will increase until the denominator is a huge number. So when the denominator is huge number, 8 over infinity becomes 0. Right? So that means for the x is a huge number. So 8 over x squared plus 4, when your x is infinity, this becomes 0. When it becomes 0, 1 minus 8 over x squared plus 4 becomes 1 minus 0. Therefore, it tends to 1. That's why here I get two extreme values, 1 and 0. Okay, so because of this reason, our range f is between 0 and 1. Okay, so that's the explanation to get the range of f. Right? Now, C. Explain why the composite function ff cannot be formed. Okay, just for information, if you need to form composite function ff, look at this diagram. This is ff, means that the first function is f, the second function is f. So here f, here f. This is a domain f, this is a range f. At the same time, this is also domain for the next f. Let's say I use, this is second f. Alright, so from here, you must understand that, right, the domain for the ff to be defined, the domain of the f must be the subset of the range f. Okay, so the df must be the subset of range f. Okay, so let me write down the range first. Range f, just now we have found fx between 0 and 1. Okay, but then the domain f, your x is greater than 2. Okay, so from here, right, your domain f is not the subset of range f. Okay, therefore I will say that the range f I would say FF cannot be formed because range F does not include the whole domain F. Okay, so this is the reason the FF is not formed. Alright, because your range F is smaller set. Okay, range F is smaller set, your domain F is bigger set, 2 onwards, but then your range F is just limited to 0 and 1. Okay, between 0 and 1. Alright, that's the reason. Alright, so now number 7, you are given 2 graphs. One is curve, one is straight line. So curve and straight line both intersect at A and B. So A, find the coordinates of A and B, means you need to find the intersection points. So now, when you find the intersection points, means that you are solving simultaneous equations. So I will just write 3x minus 2 to the power of half equals to half x plus 1. So to solve this, because of the degree half, we need to square both sides. Right, so I square both sides. So when I square both sides, the half and degree 2 can be cancelled off. Then I will just get 3x minus 2 on the left hand side. And then the right hand side, you need to do the quadratic expansion. So square of half x, it will be 1 over 4x squared. Then 1 over 2x plus times 1 times 2, it will be plus x. Then last term is plus 1. So now I move all the terms to the right hand side. It becomes 1 over 4x squared plus x plus 1 minus 3x plus 2 equals to 0. Okay, so from here, 1 over 4x squared plus x minus 3x is minus 2x. Plus 1 plus 2 is plus 3 equals to 0. So to solve the A and B, obviously the A and B are positive values. Then I need to times the whole equation by 4 to get a better quadratic equation. So I will get x squared minus 8x plus 12 equals to 0. Then I can factorize this into 2 linear factors, x minus 6 and x minus 2 equals to 0. Hence my x will be 2 and 6. So obviously your A is with x coordinate 2 and the y is with coordinate 6. Right, the x coordinates. So after you found this, then you can just substitute into the straight line equation to get the y coordinates. So now at A means that the x equals to 2, the y is half bracket 2 plus 1, which is 2. Okay, at B means that the x is 6, so the y is half times 6 plus 1, which is 4. So from here, I will just rewrite my A is with coordinates 2, 2, my y with coordinates 6, 4. Okay, so done for the A. Now B, hence find the area of region enclosed by the curve and line. Okay, so let's go back to the graph. So obviously the shaded region is bounded by the graph and the straight line. So we need to integrate from 2 to 6, but the curve minus the straight line. Okay, so now my area is to integrate 2 to 6, the curve minus straight line. So the curve is 3x minus 2 to the power of half. The straight line is half x plus 1. Then now we need to integrate directly. So when you need to do the integration, so integrate ax plus b to the power of n dx, whereby the n is not minus 1, then it will be ax plus b to the power of n plus 1 over n plus 1, and differentiate ax plus b is a, then plus c. Okay, so then I'm going to apply this formula. It will be 3x minus 2 to the power of half plus 1 is 3 over 2. divided by 3 over 2, and differentiate 3x minus 2 is going to be 3. Then minus, when you differentiate half x, it will be x squared over 4. This minus you times in, it becomes minus 1. Differentiate minus 1 is minus x. Then now limits 2 to 6. Okay, so for the denominator, I'm getting 3 over 2 times 3, which is 9 over 2 here. This is basically 9 over 2. But then when you have numerator divided by the constant, divided by the fraction, I can move up the fraction. So it becomes 2 over 9. Okay, and now I replace the x by 6. So it will be 3 bracket 6 minus 2 to the power of 3 over 2 minus 6 squared over 4, then minus 6. All of this minus the x when it is 2. So I will get 2 over 9. Then 3 bracket 2 minus 2 to the power of 3 over 2 minus 2 squared over 4, then minus 2. So just replace the x by 6, then minus when the x by 2. Okay, so when you calculate this, it will be 2 over 9, 16 to the power of 3 over 2, minus 36 over 4, then minus 6, then minus, this is going to be 2 over 9, bracket 4 to the power of 3 over 2, 2 squared over 4 is 1, then minus 2. Okay, so here you will get negative 7 over 9 minus negative 11 over 9. So at last, you will be getting 4 over 9. So this will be the area under the curve. Okay, next question, number 8. The curve y equals to sine x is transformed to the graph y equals to 4 sine half x minus 30 degrees. Describe fully a sequence of transformation that have been combined, making clear the order in which the transformations are applied. Okay, so now, see, y equals to sine x, you change to y, transform to y equals to 4 sine half x minus 30 degrees. Okay, so the transformation will be the first is translation. Okay, so I will let 12x, not 12x, half x minus 30 degrees. I need to consider the x first. From x change to half x minus 30 degrees equals to 0. Then from here, my x will be 60 degrees. Right? Means that I'm moving the graph, the original graph, 60 degrees to the right hand side, and without changing the vertical axis. Right? Means that my translation equals to 60 degrees and then 0. That is my first transformation. So done for the x. And then the next is the 4. Okay, so the second transformation is stretch. Okay, wait. I will say that I'm moving to the right hand side. Okay, 60 degrees because of this. Now you look at here. At first x, second, the new function becomes half x. So it means that this is a stretch in the x-axis or in the x direction. Okay, so stretch in the x direction with scale factor 2. Because your x has been changed to half x. Just now I just consider the minus 30 means that it is a translation. Okay, now the last one will be regarding the 4. Okay, regarding the 4. So the 4 will give you the effect on the y values. Therefore, this is a stretch in the y direction with scale factor 4. Alright, so that's the 3 transformations that have been applied in this question. Okay, so done for the 8A. Now B, find the exact solutions of the equation 4 sine half x minus 30 degrees is 2 square root 2, whereby the x defined from 0 degrees and 360 degrees. So now 4 sine half x minus 30 degrees is 2 square root 2. So sine half x minus 30 degrees, the 2 can be cancelled off. So here 2, this one will be 2. So this 2 on the left hand side move to the right side, becomes divide. Okay, so it becomes square root 2 over 2. So square root 2 over 2. So now I will get half x minus 30 degrees is inverse sine or arc sine, square root 2 over 2, which is 45 degrees. Okay, now by looking at the domain here, 0 to 360 degrees. Now I will get the domain for half x minus 30 degrees. So half x which means from 0 to 180 degrees. So half x minus 30 degrees means that 180 minus 30, you get 150 degrees. And then 0 minus 30 degrees will be negative 30 degrees. So we can accept all these values. Alright, so now I will get half x minus 30 degrees. Firstly, inverse sine square root 2 over 2 is 45 degrees. So now I will sketch a graph, sketch a quadrant. So sine is positive, means first and second quadrant. And I know that these two are 45 degrees. Okay, so by looking at this interval, means that my first angle is going to be 45. Okay, because it is from negative 30 degrees. Negative 30 is counted from the bottom, but then there's no angle here, so we just ignore. So it means that we count 45, and the next one is this value. Okay, as long as it is less equal to 150. So when you count, the next value is 180 minus 45, which is 135 degrees, which is a major red region. So as long as these two angles are within the interval, that means we are safe. So now half x equals to, just move the minus 30 degrees to the right side. It becomes 75 degrees and 165 degrees. Okay, so then you times 2 for both degrees, it will be 150 degrees and 330 degrees. So that's the solution for this question. Okay, so now question 9. The equation of a circle is x squared plus y squared plus 6x minus 2y minus 20 equals to 0. Find the coordinates of the center of circle and the radius. Hence, find the coordinates of the lowest point on the circle. Okay, so for this case, we need to find center, radius, and the lowest point. Right, so to get the center and radius, we need to complete the square. So when we complete the square, I need to arrange first x squared plus 6 squared, and then y squared minus 2y minus 26 equals to 0. Or you can just move the minus 26 to the other side because we need to get radius. So now I complete the square separately, x and the y. Okay, so x squared plus 6x plus square of a bracket minus square of bracket. This is for the x. Then for the term inside the bracket, it will be the half of coefficient of x. That means it's 6 over 2. Same goes to the y. So y squared minus 2y, then plus bracket squared minus bracket square, then equals to 26. So the term inside the bracket will be half of the coefficient of y, which means minus 2 over 2. Alright. So now I can simplify. Combine first and third term. It will be x plus 3 because 6 over 2 is 3. Then here is minus 3 squared plus the first and third term inside in the y, in terms of y, it will be y minus 1 squared, then minus 1 squared equals to 26. Then from here, all my constants will be moved to the other side. It becomes 26 minus 3 squared is minus 9. So now becomes plus 9. Minus negative 1 squared is minus 1. So move to the right side, becomes plus 1. Okay, so here I will get x plus 3 squared plus y minus 1 squared equals to 36. This 36 is 6 square. Okay, now in order to get the coordinates of the center, right, I will write x minus 3 squared. I will write in general form so that we can read the coordinates of the center and also radius directly. So once you have obtained this form, that means the center is with coordinates minus 3 and 1. Then the radius will be 6. Okay, so now what is the lowest point, the coordinates of the lowest point? So now look at here. Let's say this is your circle. The center here is minus 3, 1. Radius is 6. That means here is 6. Alright, so the lowest point will be with the same x coordinate, minus 3. But then your y coordinates means that you have to move down. Okay, move down 6 units from 1. That means this is 1 minus 6, which is minus 5. So I'm getting this lowest point. So therefore, lowest point with coordinates minus 3 and minus 5. Okay, this is how we get it from the diagram. Okay, now B, find the set of values of constant k for which the line with equation y equals to kx minus 5 intersects the circle at 2 distinct points. Alright, you need to find a k. Okay, so when 2 distinct points means that you are getting 2 roots. So now y equals to kx plus 5. I let this be the first equation. My second equation will be the circle equation. So I will rewrite this original circle equation. Okay, so x squared plus y squared plus 6y minus 2y, plus 6x minus 2y minus 26 equals to 0. So I will let this be second equation. Now I substitute first into second. Alright, so x squared plus kx plus 5 squared plus 6x minus 2 of kx plus 5, then minus 26 equals to 0. So I will do expansion. So x squared plus square of kx plus 5 will be k squared x squared. I'm going to use quadratic expansion, a plus b squared, which is a squared plus 2ab plus b squared. Okay, so then the second term is going to be, the next term is going to be 2ab. So it means that 2 times 5 is 10. 10 times kx, you get 10 kx. Plus, the 5 squared is 25. Then, copy the 6x. Here, we do expansion. So, minus 2kx minus 10 minus 26 equals to 0. Alright, so now, we need to get 2 distinct points. And our concern is to find a k for which it has both of them have 2 distinct points. So it means that now I need to group the x squared. So it will be 1 plus k squared. Okay, then I get the x as a subject. By factorizing the x, I will get 10k plus 6 minus 2kx. Alright, so 10k minus 2k will be 8k. Then plus 6. Okay, I check back my working. This is minus 5, but I wrote positive 5, so I have to change back. Change plus 5 to minus. So here kx minus 5, minus 5, minus 5. So when I do my expansion, second term here will be minus, and then with this minus, okay, minus 2kx becomes plus 10, then minus 26. Okay, here is plus 10. Mistake. So now, when I simplify, here is minus 10kx. Look at here. Minus 10kx. Here is minus 2kx. So when you get the total, it will be minus 12kx. Right? The plus 6, no change. Then plus, the rest just combine. Means that now you have 25 plus 10. It will be 35. 35 minus 26, it will be plus 9. Okay? Then equals to 0. So now, two distinct points. So, two distinct points means b squared minus 4ac is greater than 0. Okay, but before that, let me write down what is my ABC first. So here, I will write my a is 1 plus k squared. My b is minus 12k plus 6. Then my c is 9. So b squared minus 4ac greater than 0. Now replace the k value, the b values, minus 12k plus 6, square it, minus 4. The a is 1 plus k squared. The c is 9. Then now again do expansion, quadratic expansion. So here I will get 144k squared. When you square minus 12k, it will be 144k squared. Now negative 12k times 6 times 2. Okay, it will be minus 144k. Then the 6 squared, it will be 36. Now, this 4 and 9, when you times together, is 36. So, 36 multiplied by 1 plus k squared, you will get, you see, there's a negative outside. You will get negative 36, then negative 36k squared, greater than 0. Okay, so now simplify the k squared. 144k squared minus 36k squared. You will get 108k squared. Then negative 144k. The 36 and minus 36 will be cancelled off. So here greater than 0. Alright, so now I can factorize k from both terms. Then you'll be getting these two terms. And I notice that 108 and 144 can be divided by 36. So I divide by 36 first to simplify it. So it will be 3k minus 4. Okay, now to solve this, look at the quadratic equation. It was 108k squared minus 144k squared. So when you look at this quadratic equation, means that the coefficient for k squared is positive, which means when I sketch a graph for the k, for the axis k, it will be having a minimum point because it is positive k squared. Alright, so my k values will be 0. I let this be 0 because when here is equal sign, k equals to 0. Then another one here is 4 over 3. So it means that when I label, here is 0, the other one is 4 over 3. And both graph is greater than 0. So when greater than 0 means that our values will be above the k-axis. Okay, therefore, your final answer, k is less than 0 or k is greater than 4 over 3. So that's the solution for this question. Okay, now question 10. The equation of a curve is such that d squared y over dx squared equals to 6x squared minus 4 over x cubed. The curve has a stationary point at minus 1, 9 over 2. Determine the nature of the stationary points at minus 1, 9 over 2. Okay, so nature of stationary points means maximum or minimum point. Maximum or minimum point, right? So it can be decided by substituting the x value into the d squared y over dx squared. So now I will just write as x equals to minus 1, d squared y over dx squared will be 6 times negative 1 squared minus 4 over negative 1 cubed. So here is going to be 6, then minus 4 over negative 1. So at last, you will get positive 10. So positive 10 is greater than 0. Therefore, minus 192 is a minimum point. Right? Now find the equation of the curve. So for your information, from y we differentiate once, you get dy dx. Okay? Then you differentiate one more time, you will be getting d squared y over dx squared. So now you are given the d squared y over dx squared. To get the y, we need to use opposite direction, which is a reverse process, which means integrate. Okay? Because integration is the reverse process of differentiation. So it means that now you need to integrate 2 times. So d squared y over dx squared is 6x squared minus, okay, since we need to do the integration, instead of writing 4 over x cubed, I will move up the x cubed. So because 4x power negative 3. So 4x to the power of negative 3. So now I will integrate. So when you integrate the d squared y over dx squared, you will be getting dy dx. So now I will write dy dx equals to integrate 6x squared minus 4x power negative 3 dx. So when you integrate 6x squared, it will be 6x cubed over 3 minus 4x. Now, when you integrate, you plus the degree. So minus 3 plus 1 becomes minus 2 over minus 2 plus c. We can simplify this to be 2x cubed plus 2x power negative 2 plus c. Okay, so this is our dy dx. So now we need to find the c first before we proceed to the next integration. So now we get the idea from the A. Stationary points at x equals to minus 1. So whenever stationary points means that dy dx equals to 0. So from here I get the idea. When x equals to minus 1, dy dx will be 0 because that is the stationary point. So now from here, 0 is 2 times minus 1 cubed plus 2 times minus 1 to the power of negative 2 plus c. So my 2 times minus 1 cubed is minus 2. Minus 1 to the power of negative 2 is 1. So 1 times 2 is 2. Therefore, my c is 0. Okay, now I rewrite my dy dx. So my dy dx is 2x cubed plus 2x to the power of negative 2. And now to get the y, I need to integrate the dy dx. Okay, so now my y will be integration of 2x cubed plus 2x to the power of negative 2 dx. So when I integrate 2x cubed, it will be 2x degree 4 over 4. Okay, plus 2x. The degree at first negative 2. Now when you plus 1, it becomes minus 1. Then over minus 1 plus d. Because just now I have used the c, so now I use d. Then when you simplify, it will be x degree 4 over 2. The minus 1 you can times to the 2, and then it becomes negative 2 over x because the x with degree minus 1. So I will move it down. Then plus d. Okay, that is my y. Now, how do I get this d? I need to get the values of x and y. So the x and y, I may refer to the point. So x is minus 1, the y is 9 over 2. So now, x is minus 1, y is 9 over 2. Okay, therefore, 9 over 2 is minus 1 degree 4 over 2 minus 2 over negative 1, then plus d. So 9 over 2 equals to minus 1 degree 4 is 1. So I will get half. Then 2 over negative 1 is basically minus 2. So this minus and minus becomes plus 2. Okay, so my d is going to be 9 over 2 minus half minus 2. So then you will get 2. So lastly, my y is going to be x degree 4 over 2 minus 2 over x plus 2. That is the equation of the curve. So here you may write equation of the curve. Okay? That's the solution of this question. Right? So now, C, show that the curve has no other stationary point. So now we need to differentiate dy dx. So my y equals to, or I can just write my dy dx, no need my y, okay? So I will just copy dy dx is 2x cubed plus 2x power negative 2. That will be easier. 2x cubed plus 2x to the power negative 2. So now, when stationary points means dy dx equals to 0, I will write equals to 2x cubed plus 2 over x squared. I'll try to find the x values. So from here, get the same denominator, x squared. Then the first term, you multiply 2x cubed with x squared. It will be 2x degree 5 plus 2 equals to 0. So when you solve this equation, which means 2x degree 5 plus 2 equals to 0, on other words, x degree 5 is minus 1. So it means that your x only has one value, which is a minus 1. So x equals to minus 1. Just now you are given the stationary point. This is the only stationary point you have. Okay, because we only get one x values when the dy dx equals to 0. So you can just write only one x, or only one stationary point, which is at x equals to minus 1. Hence, the curve has no other stationary points. Right? Because there's only one x value. That's why only one stationary point. Now D, a point A is moving along the curve and the y coordinates of A is increasing at a rate of 5 units per second. So from here I will write dy over dt equals to positive 5. Now find the rate of increase in the x coordinate. So you need to find dx dt is how much when x equals to 1. Okay, so now for this case, I need to write down my dy over dx first. My dy dx is 2x cubed plus 2 over x squared. Alright, so at x equals to 1, because now you need to find the rate of the x at x equals to 1. So at x equals to 1, my dy dx equals to 2 times 1 cubed plus 2 over 1 squared, which means it's 2 plus 2. Then you get 4. Okay, so now dx over dt can be found using the chain rule. So it will be dx over dy times dy over dt. So dx over dy is 1 over dy over dx. Therefore, it is 1 over 4. dy dt is 5. Here I get 5 over 4. The unit is units per second. Okay, so that is the rate of the increase because we are getting positive 5 over 4. Alright, so that's the end of this video. Alright, so thank you for watching and please subscribe to Math World YouTube channel and stay tuned for more upcoming videos. Thank you. Bye.